Login accepted.
Let me redo that for all the people who are on Zoom. Hello, everybody. Welcome once again to a Swift meeting. My name is Clemence, and today we are going to be doing an introduction to Git. First of all, here's a very, very flattering photo of myself, posted probably by Sydney. So just a quick introduction to myself. Thanks so much. I am a CIS senior. I'm co-director of comps. I am certified currently in Linux Plus and Security Plus. If anybody here plays Space Engineers, please let me know. I am in desperate need of somebody to launch my creations against. I can't believe you still have this picture. All right, just a quick rundown of the previous schedule. Currently, we're on week whatever this is for Intro to Git. This Friday is the Mr. Tech Mixer, but I've been told not to promote that because they are full. And for the rest of this month is going to be Scare. Once again, we're going to ask you guys to become a member. Memberships, we have two tiers of members. We have the free tier, which basically means just join the Discord and you're essentially a member. And we also have the paid tier, which costs $35 for the year or $20 if you want to pay for the fall semester. We have special perks such as our alumni mentorship program, a special stole for our graduating seniors, and some special t-shirts, stickers, bundles, things like that. Our Pumpkin Patch Social is coming up. It's going to be on Saturday, October 19th, and we're going to meet together at 2 p.m. in front of the dates. In front of the gates. Go ahead and purchase your own tickets, and we can all meet up together there. I can't believe you guys are using the 2 years ago pumpkin patch picture. CSAF is also coming up on Thursday, October 17th from 10 a.m. to 2 p.m. It's going to be at the BSC. For those of you guys who have never been to the BSC, it is that gigantic building all the way at the other end of campus. Yes, I know it's a walk. We're going to have a lot of professional demos from a whole bunch of people. We are going to have a booth there. I have no clue what we're presenting, but we're presenting something. FAST is also going to present something. Miss Witt and other clubs are going to do demos. And we're also going to get some companies like Intel and Cisco. So some good stuff. And now let's go ahead and talk about the stuff that we're going to talk about today. So first of all, I'm going to go over what Git really is. I'm going to talk about some hosted providers, and then I'm going to give a very, very, very basic crash course into how to use Git. All right, what is Git? Git is what is known as a version control system. What this essentially means is, has anybody here opened up a code project and made a whole bunch of changes to it, and then really wish that you could go back and see what changes you had made before? All right, that's like 2 people, 3 people. Okay, for those of you guys who have not done code projects and will do code projects in the future, this is a problem you might run into at some point in time. Now, one quick solution to that is the version control system. This basically tracks the changes that you have made to the code over a period of time. It allows the management and tracking of these changes. Not only that, but one of the best benefits of Git is that it allows you to merge changes from multiple different contributors on multiple different computers. Let's say that I make a change on my laptop. I push it to the main repository. I'll talk about these terms a little bit later. And I can then go onto my desktop at home, and I can grab those changes from the server, and I can work on them. Also, we could have Bill work on his changes and put them into the main code base later too. Or Sydney can do it, or Charles, or anybody can put code in. Not only that, but it allows for something called conflict resolution. Now, for anybody here who has done anything with Git before, you've dealt with conflict resolution, and this is incredibly important because sometimes I make a change. For example, I set x equals 5. But then let's say somebody else has set x equal to 3. Well, then now we have to decide which one we want to keep, and we can go ahead and do that through Git's conflict resolution system. First of all, we have to talk about the branch model. So essentially, Git uses branches to manage every single version of the code. There is something called the main, master, or blessed branch. This is going to be the central code base. Every change eventually gets added to the main branch. Pretty simple. And every individual developer or every individual version or feature has their own individual branches. So I could have the Clemence branch, Sydney could have the Sydney branch. We could also have a branch for version 1.0. We can have a branch for version 2.0. Heck, we can even have a branch for version 13.0 way far ahead in the future that we can already start to push changes to even now. The great thing about this is that branches can be created and deleted extremely quickly and extremely easily. With this, we can create something just to test out a new feature. We could say like, hey, what if I want to add this cool new code snippet? I try it out and it's like, oh, you know what? It turns out it actually doesn't improve anything. And in fact, it slows down the program by about 50 times. Then I can just go ahead and delete that and nobody ever has to know that you created something so incredibly inefficient. There are many possible workflows for Git repositories. For example, the most common for smaller projects and smaller teams is going to be the subversion. With subversion, you have a very, very centralized workflow. You have the shared repository with the main branch, and every individual developer, or if you're the only developer yourself, can push changes to this shared repository. Now, the only downside to this model is that there is no protection. So let's say that I introduce a bug in my own working version of the code. And if I upload that bug to the shared repository, now everybody has to deal with a gigantic bug, and then we spend 5 weeks trying to figure out what exactly happened. For slightly larger teams, now we have something called the integration manager model. With this, we have the main branch, and only one person can really push to it, or one group of people. These are the integration managers. The integration manager's job is specifically to review any code changes, test it out, make sure that there are no bugs, and if they are good to go, then push them to the blessed repository. Every individual developer has their own private repositories on their own computers. They can push those to the public branches, and those public branches can be integrated with the blessed repository as needed. But what if we have an extremely large project with hundreds of thousands of collaborators and contributors? Can anybody tell me about such a project that has such a huge number of contributors? Exactly. The Linux kernel itself uses Git as its version control system. And funnily enough, actually, Git was invented by Linus Torvalds as a way to manage the Linux project. With the Linux project, we have the dictator-lieutenant model. It is an incredibly decentralized version of the code. Of course, as before, you have the blessed repository, and everybody can pull from that. But in this case, only one person, the dictator or Linus Torvalds himself, can push to the main Linux repository. But he cannot just manage every single developer's branches. I mean, again, there's literally hundreds of thousands of developers for Linux. So what he has is he has various lieutenants who are each in charge of various parts. For example, you might have someone in charge of drivers. You might have somebody in charge of making changes to, I don't know, file system? I don't know. But the point is you have individual people managing individual parts of the repository. And you have developers who, for example, I make a change to a very, very basic part of how the kernel works. Then I push it to the appropriate lieutenant. That lieutenant reviews the code and then sends it to the dictator. And from there, the dictator will go ahead and review that code. And if it works, then they can push it to the blessed repository. It is much slower. It's much more bureaucratic, but it is a safer way of managing such a large number of people. Let's go ahead and talk about GitHub. Now, I'm sure everybody here has at least heard of GitHub in one form or another. But GitHub is one of the main cloud-based Git repository hosts. Basically, it allows you to access your code from anywhere without having to host your own private repositories. And not only that, but GitHub has also expanded to include a large number of services for developers, including Actions, which is continuous integration, continuous development. You have projects, which are task boards. You have gists, which are simple code snippets or even rants if you want to do that. You have packages, which allows for npm package management, and I think they're expanding to other languages too. And then you have pages, which essentially allows you to build your own website without having to use something like WordPress or something like that. It is very easy to publish indie code projects or even larger code projects and have them accessible to all kinds of people. And best of all, GitHub is usable for free, especially if you're just trying to manage your own code repositories. Of course, for businesses, you can go ahead and create pro versions of this, and you can have special controlling features for those teams. But yeah, GitHub. Of course, GitHub isn't the only major code repository out there, but they are by far the largest. You have options like Bitbucket from Atlassian if you want to use Atlassian services. You have GitLab, which is, I believe, a fully open source version of all this. You have SourceForge, which has had a bad reputation in the past for hosting malware, but they're getting a little bit better. You have AWS Code Commit if you prefer to stay within the AWS side of things. You have Launchpad, and you also have Azure DevOps in case you want to stay within Azure, which is kind of ironic, honestly, because GitHub is owned by Microsoft. So why would Microsoft own a company that has a Git? Okay, anyways. And now let's have a very, very big crash course into Git. Here's a quick note. I have gone through and I've included things very much like a Linux terminal. But for general Git commands, you're always going to have Git prefacing anything, and then your sub command from there, and your options. All right, let's go through a couple of basics here. The first one is init. Init is short for initialize, and it basically means you're going to create a blank repository or reinitialize something. We're not going to worry about reinitializing. It's a special case of repositories. But essentially, let's say I have a code base and I want to start managing it. Then I just type into the command line git init, and yeah, now I have a brand new Git repository. It's set to track any changes, and you're good to go. But let's say I want to contribute to an existing repository, or I simply want to just grab some code. What I'm going to do here is I'm going to do something called git clone. Basically means you're taking a repository, an existing repository, and you're copying its code and changes directly onto your computer. So the syntax for this would be git clone and then the location of the Git repository. Now, Git does support multiple ways of accessing your repositories. The most common these days tends to be over HTTPS, but considering how that is slightly insecure compared to the other options, or somewhat inconvenient sometimes, we also have SSH access, which is more and more popular these days. In which case, you do something like git clone user at website and then the repository location, or you could even just use the FTP protocol if you really want to. Although I've never seen anybody actually use FTP for Git repositories. Remote. So technically speaking, when you're contributing to a Git repository that is not locally hosted, you're contributing to a remote. This is the central location where that Git repository is hosted. So typically, people will put it on GitHub. So you'll set your remote to something like https://github.com/ for example, Entangled Labs / whatever. Yes, that is my actual Git username. You can make these private. If you want to have a private remote, there are ways to set it up on GitHub for only private access, in which case you'd have to make sure to log in with a special token. If you set up your own private repositories on your own servers, you'll have to log in with your own user management system. But if you want to add a remote or remove a remote, it's pretty simple. You just do git remote, add or remove, and then the name of the server, and then the URL. So for example, here we have git remote at origin https://example.com/gitrepo.git. That's not an actual repo. I just put that there as an example. Now, origin is a keyword that is typically used for the main code base. So most of the time, if you hear somebody saying that they want to push to origin, that's what they mean. Okay, now I've been saying push this entire time. But what does push actually mean? To push something means that you are sending your code and your changes and the history of those changes from your local dev environment all the way to the remote environment. Basically, it's kind of like uploading your stuff to the server. It's pretty simple. What we're going to say here is we're going to do git push, the name of the remote, and then the name of the branch that you're pushing to, the name of the branch you're pushing to, because by default, it just pushes whatever you're working on right now. So in this case, we're going to do git push origin main. So we're pushing to the origin remote, and we're using the main branch. Fetch means that you're going to grab the latest changes from the remote. This is important. If anybody has done like Linux package management, then you'll know that there's a difference between updating and upgrading. This is kind of similar. With fetch, you're just grabbing the changes. And then if you, later on, I'm going to discuss pulls, which basically means you're going to actually merge those changes into what you have. So the syntax for that is get fetch, or if you want to literally grab everything, just do -a. Honestly, most of the time I just do get fetch -a anyways. So yeah. And now pull. As I said, pull basically means you're integrating the latest code changes from the remotes to your local dev environment. This is useful if you have not, for example, updated your code in 365 days. Then you can update it and say, oh crap, now I have 300,000 things to track. But the syntax for that is very simple. It's literally just git pull. And yeah. Does anybody have any questions on these basic commands before we continue? Yes, sir. So basically what pull does is it takes the changes that have been made to the to the remote, such as origin, and it integrates it with your local development environment. So for example, let's say that you push something to the remote and you added a variable. Now, of course, until I sync with the server, I'm not going to have your change. So if I do a git fetch, now my computer knows, hey, you've made the change. And then if I do a git pull, it's going to say, hey, I'm going to take your change and I'm going to add it to my development environment. Now, of course, if you've made changes since then, there's going to be a whole mishmash of trying to figure out which version is better to apply. But essentially, it just grabs the changes from the server and puts it onto your own computer. Did that answer your question? Okay. Any other questions before we move on? Yes.
So it's like fetch. It just only gets like the commits and stuff. It won't get integrated to the.
That is correct. Fetch only grabs the changes and the history of changes, just like what update does for if you do apt update. Anybody else before we move on? All right, let's go ahead and go on to snapshot. Oh, wait, is there anybody on Zoom that has questions? Nope, nobody has questions on Zoom. All right, now we're going to talk about snapshotting. Who here can tell me what snapshotting is? Okay, black group. Snapshotting basically means you're taking an image of what has happened or what is currently happening. Basically, this means that we are going to go ahead and we're going to take a log of what has changed and for example, what's been added, what's been deleted, and we're putting that on record so that we can access that record later. And this is where we're going to get the idea of the commit. A commit is a record of changes to a repository. Let's say I've added test.py. And let's also say that I've compiled it a couple of times. I have a binary that I want to push for some reason. So now I've added test.py. I've added the executable. And I want to push this to the main repository. So what I'm going to do is, now that I have this record of changes, I'm going to commit it. I'm going to put it on record. I'm going to say, hey, these changes exist. So if I do git commit -a, that means I'm going to commit everything that has been added so far. A -m just means that I'm going to add a specific message here. Typically, you want your git commit messages to be short, descriptive things. Yes, it is very common for developers to put something like, oh, I changed a few things. Great, thank you very much for the long descriptive sentence. I know exactly what's been changed with that. What is better to do instead is to say something like, added new algorithm for controlling the car, or fixed a minor bug in such and such code file. With that, then people who actually are reviewing the code history over time, they can see, oh, look, Kenneth has made certain changes here, and this is exactly what they've done without having to actually dig into the code to figure out what exactly they did. Of course, if you don't use the -m option, what will happen is a code editor will pop up. If you're using Linux, it does default to Vim, I think. And if you're on Windows, you have like 30 different options for code editors. So for example here, if I do git commit -a-m made an important change, it's going to commit all of the changes with the message made an important change. Again, please don't actually use that kind of messaging. Please actually put descriptive stuff. As a developer, I am begging you to do this. Status shows the status of your local environment, as is quite descriptive. It indicates what is being tracked, so the changes that have been made, the number of kits and the number of commits that are being pushed or pulled. Basically, this says, for example, let's say that there's a whole bunch of changes on the server, and I've also made a lot of changes, and I've committed all those changes. You'll see something, for example, that says three to pull and then 2 to push. What that means is that there are 3 changes that can be pulled into your local environment, and you have 2 changes to send to the server. This is really, really useful if you have not kept track of what exactly you're doing right now, and you want to know what is going to be changed when you do any future steps. Syntax for that is pretty simple. It's literally just git status. I personally spam this like 10 times every single time I make a couple of changes that I want to commit. Apparently, I forgot to add a very, very important slide here. So we're going to go back to commit. OK. Now, when I say git commit, and I very specifically said that it's a record of things that you have added to be tracked. Now, this is very specific because not everything that you automatically, not every change that you make or not every file that you add or delete automatically gets tracked by Git. If you do a git status after you've added a new file or you've made changes to a file, what's going to happen is you're going to see a whole bunch of red and a whole bunch of green. The red means that that stuff is not being tracked. It means that Git does not care what has happened there. It's not going to even touch it. What green means is that Git says, hey, I recognize that these changes have been made, and I'm going to keep track of that. So what we're going to do is we're going to do something called git add. A git add means that you're going to add certain files to be tracked. So for example, let's say I made a change to the main.py file. If I do git add main.py, all of a sudden it's going to change from red to green, and it's going to say, hey, I am now tracking the changes done in this file. But there is also a very annoying thing that does happen, especially when you're compiling your code. When you're compiling your code, especially in Python, what happens is you get a whole bunch of binaries that are generated, and those binaries tend to be convoluted, sometimes a little bit heavy, and honestly, they're really not necessary for your code development, especially since they are compiled specific to your local environment. What you want to do is you want to make sure to ignore those files every single time. So what we're going to do is we're going to add something called a git ignore file. This is a very, very useful file. It literally, you just create a file called .gitignore. And basically, if you put certain patterns into the gitignore, it does follow standard regex. So if you know regex, you can put it there. If you don't know regex, just like Google regex tester or something like that. You can test out those patterns pretty easily. And you can test for certain patterns. So the Python compiled binary files are .pycs. So if I just put asterisks .pyc, it's going to ignore every single pyc file from here on out, which is very, very useful. So once you've added something, then you can go ahead and commit those added changes. Because again, unless you add something, it's not going to be tracked. All right, before we continue, does anybody have any questions about snapshotting? Yes, sir.
Git add is basically whatever code you git add on,
Mhm.
basically make something that's going to be tracked with.
Exactly. Anybody else? Going once, Going twice, going 3 times, not sold to anybody. Okay, now we're on to branching. Once again, branching basically means that you can have different versions of code managed or developed by many different people on different computers, and none of it will really affect what happens to the main unless we start to merge our changes together. Again, branch version of code can be changed or deleted. Very simple to create a new branch. You have git branch and then the name of the branch. And for example, if I do git branch new feature, then I create a new branch that's called new feature, and I'm automatically switched over to that new branch. So great. Now I can test out the new features that are going to be added in the branch new feature. But let's say I want to switch back to a different branch. Let's say that there's code in a different branch that has been added there, but has not necessarily been added to your own branch, and you want to test something out. Or let's say you're responsible for many different features, and you don't want to cross-contaminate the code. Well, the checkout command will allow you to switch branches. And it's, once again, similar to branch, it's pretty simple. You do git checkout and then the name of the branch. So if I do git checkout main, let's say I'm already on the new feature branch, then now I've been checked out to the main branch. Now I am on the main branch. Pretty simple. Now we have merge. Merging is when you combine 2 branches and their histories together. This can be a very annoying process sometimes, especially with merge conflicts, but I'll go ahead and talk about merge conflicts after. So basically what I'm saying is let's actually let me go back all the way to here. Okay, this is an example of what a Git tree would look like. You have the master branch or the main branch or the blessed branch. You have development branches and you have individual topic branches. Now, every single time you see an arrow come out, that is a different branch. So, for example, the development branch has been branched off of the main from the start. It means that any changes there are, separate, and they're tracked separately. Now, if you notice, there is a line connecting the development branch to the master branch. That indicates that code from the development branch is now merged onto the master branch. It means that the history from development goes directly into master. So for example, let's say I may change A, B, C, and D in development, but master is stuck on A, commit A. If I merge the two, it's going to take a look at all of that. It's going to say, hey, the development branch is A, B, C, and D, but master only has A. So I'm going to go ahead and add everything from B, C, and D directly onto onto master. So now master has the record of A, B, C, and D. If we have, for example, somebody who pushes something to development, let's call that commit F. But master already has an E, but does not have an F. So from there, it'll say, okay, which commit happened first at which point in time? Then it's going to go ahead and kind of like try to merge those histories together, merge all the changes together, and try to figure things out. You can see here with these loops, people create branches, then they merge those branches, and they just go ahead and delete those branches because they really don't need those anymore. And multiple times we've gone ahead and merged the development branch to the master branch. And of course, you can have individual topic branches too. For example, this branch right here, it's branching off of the development around the same time that we've merged with master. And it's an ongoing development of a certain topic. And even from there, you can branch off the topic. You can branch off of a branch, off of a branch, off of a branch, so on and so forth, all the way until you eventually reach main. But as you might expect, sometimes we make changes that can break other changes. Sometimes you make a change to an algorithm that somebody else also is working on, and now we have to figure out what exactly to do with that. Oh yeah, and the syntax for merge is very simple. You just type the name of the branch that you want to merge to. Again, you want to merge to because it already considers your current branch, and it's saying I'm merging my current branch to whatever branch I'm specifying here. So for example, if I'm on a new feature, I can merge new feature to awesome features. This is an example of what a merge conflict resolution looks like. In merge conflict resolution, what's going to happen is Git's going to say, hey, I cannot merge these two together automatically because there are certain changes here that will break everything. So I want you to go in and fix them. Now, this is a very, very simple merge conflict where you only have a couple of changes. But with larger code bases, you can sometimes have hundreds and hundreds of changes that you have to go through and revise and check and make sure that you know which version of the code you want to keep. So, for example, we can see here on the left side, we have local changes. This is your local repository. These are the changes that you have made yourself. The result in the middle here is for it's like what's going to happen at the end after the merge is done. And then on the right side, you can see the commit that is causing problems with your own commit. So we can see here that the commit with the tag 503 blah 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 from the server, it has, for example, it has added green. Git uses the green red system, green add, red delete. Somebody added this public int getMax method right here, and they've added it to the main code. So it's going to be added right here. And they've gone ahead and deleted something here. But if we see here, I've added this code here for getAverage, but this stuff here seems to conflict with this stuff. So we need to choose which code version we're going to keep. And here we can see that we are deciding to keep the local changes rather than the changes that have been made to the server. So all of these merge conflicts eventually, once resolved, become their own commit, and they get pushed to the server as soon as you're done with the merge. Because basically you're saying, hey, I've made these changes. I've recognized that these changes get broken by another change, and I recognize that I'm making certain changes to fix the changes that have been broken by other changes. Yes, a whole lot of changes being made. But essentially, after you're done with all of these merge conflicts, you should end up with a fairly clean code base that looks as pretty as the branching that we saw at the beginning. Does anybody have any questions about branches and merging? Yes, sir.
Development, like the main.
Yeah.
Let's say there's something in the main branch that the development branch doesn't have.
Mhm.
So will they like make a new branch, or like will like commit that to the main branch that has, but the development branch doesn't? Will that commit be transferred to the development as well, or is it only one way?
Very good question. A merge is technically one way. You're merging your changes onto another branch. But you touch on a special case in which we will use something called a rebase. A rebase means that you're going to reset your current head, or like where you're tracking, to like a very specific point in time on another branch. So if I'm going to rebase with the main branch, it means that I'm going to sync all the changes that have been made in between. I realize, hey, there's a commit here on the main branch that I didn't even know existed, and I want to bring that change to mine. Of course, this brings with itself even more conflicts, and you have to resolve them the exact same way. But merging, basically, you push it to one way. Rebase means that you're resetting everything to like a common ground. Does that answer your question? Awesome. Does anybody have any other questions about merging or branches? Anybody here asleep? Anybody didn't get enough sleep last night? Less than 4 hours of sleep, anybody? Congratulations, I recommend more sleep. All right, that does do it in terms of the content I have to present today. I'm gonna go ahead and open the floor for general questions about Git. Anybody on Zoom? Any of the 20 or so people on Zoom? Hmm? Yes, sir. Yes. You don't use it directly on GitHub because GitHub is just the repository. But actually, let me go ahead and show you how to get started with Git on your own computer. So first of all, you have to type it correctly. Okay, so Git SCM is the main website where they host all of the information and all of the stuff for Git. Of course, if you're on Linux, you can do something like apt install Git. But on Windows, you would have to install like special things. There are two versions. There's Git Visual, there's Git Command Line. Honestly, do the Git Command Line. It's better in almost every single way. You can download for Windows here. You have the documentation here, and actually this documentation is extremely in-depth and very thorough. If you go to this reference manual, you see they literally have information on how to use everything here. And there's, a lot of stuff that I didn't talk about, but, there's enough to get started, really. If you download it, you have the GUI client, you have the command line client. But if you're going to use GitHub, let me go to GitHub. Let's go ahead and let's look for example. Okay, this is what a Git repository would look like on GitHub. So if we click this code button, you can see HTTPS and GitHub CLI pop up. But basically it means this is the location of the repository. So if you want to set up to track this origin or this remote, then this is the address that you want to use. Here, you can browse the different branches. So for example, we have the main branch. That's where the main code base comes from. That's where everything is built off of. But then we also have a whole bunch of other branches for example, memory profiling for CUDA. You have Mac OS something, Mac OS plus something else, a whole bunch of other models that are being added. But basically, you can set up individual branches again to work on different features. You can have folders tracked. You have individual files that are being tracked. You can set up READMEs to track everything. But again, GitHub is not your development environment. That is where you're going to store your code. What you would do is you would clone this repository to your own computer, to your own local development environment. And then you can go ahead and make your changes. You can create a new branch to track changes. And then once you're done with those, then you can push those branches and changes directly to GitHub. So you would do your git push origin main. Or, well, not to main, please, because you don't want to modify the main code base without it being reviewed by somebody. But for example, cool, awesome features branch. And then from there, what GitHub does in terms of terminology a little bit differently than regular Git is they have something called a pull request, which is literally just a merge, but it's like you're requesting to merge stuff to the main. So you're merging the two branches together. So with a pull request, what somebody does is you have somebody who is a manager, like an integration manager. They come in, they review your code, they say, hey, this is not going to break anything. This is an actually useful feature. We're going to go ahead and put it into like a special development branch or into the main branch. If I had my laptop working right now, I would give a demonstration of what Git does, but I don't. So let me just go ahead and pull up an image of Git instead. Oh, great. Here's somebody literally creating a repository. So we have Git init. You're creating your blank repository. You're creating a README file. Git add README. So now you're adding the README to be tracked, and any changes from that point forward are being tracked to README. Then you do your git commit. It tells you E4DC C69. That's the code. That's like the identifier tag for the commit. And it says one file changed, one insertion. Insertion means you've added something, and it said create mode, but I think it's supposed to say create mode. Git remote add origin. So you're adding the origin to git at github.com /that's git. So you're adding that origin so that you can push changes to that, and then git push, and then you're pushing to origin master branch. Once again, though, if you want to download Git to your own computer, literally just go to like Google Git, and it's going to be this website right here. Does anybody have any questions about this? Anybody bored out of their minds? Okay.
Okay, one final announcement. Apparently, Missa does want us to promote Tech Mixer. They do have more spots. So it is this Friday from 5 to 8 p.m. at Ursa Minor, which is on the second floor of the BSC. They're going to have a speaker panel first from all these companies, and then they're going to have like rotations where you can individually talk to all the speakers. There'll be food and refreshments, and be sure to scan their QR code to sign up. We'll post this in announcements too, in case you missed this. But yes. Yay.
Oh yeah, and if you do message Vinny today, please tell him happy birthday because he is celebrating his birthday right now.
Aw. Yay. Okay. We could leave the room now. It is 12:45. I think there's another class, but thanks for coming, guys. Gonna end the Zoom.
Stop this.